Hello National 5, it's Mr. Neil here, and this is our second video where we're looking at database design. And in this video we're going to be focusing in on data dictionaries. For the purposes of National 5 Computing Science, you need to be able to describe and exemplify a data dictionary and all the different components that make up a data dictionary. That means that by the end of this video you'll be able to produce a data dictionary, identify and describe primary and foreign keys, identify the different types of data that can be held in a database table, and identify and describe the different types of data validation that can be used within a database. Firstly, what is a data dictionary? Well, a data dictionary is a design document that outlines how a database table or entity will be built. For example, here is an extract from a data dictionary. The data dictionary specifies the fields or the attributes within that table or entity, the primary and foreign keys, the type of data within each field, the length of that field, if that field is required, or any type of validation that we can have. This is then used to implement and create the table, and then we can see here is the entity or table contents. So we're now going to have a look at a couple of these headings in a little bit more detail. Starting with keys. In the video and entity relationship diagram, we explain the difference between primary and foreign keys. The primary key is an attribute that uniquely identifies each record in an entity, whereas the foreign key is used to link the two entities together. So it's the primary key from one entity included in another. We then need to think about what kind of data is our attribute or field going to store. So fields can store text, they can store number, they can store date, they can store time, and they can store Boolean. Couple of things to note. For example, a text doesn't just have to be text, it can be a combination of text and number. If your value begins with 0, this is a text data type and not a number, because if we have a leading 0 in a number data type, we get rid of that leading 0. So for example, this here being a Scottish candidate number, it's really important that that leading 0 is there, that's why it's text. Date and time are relatively straightforward, and Boolean can either have two values, so true, false, yes or no. For data types that are text, we also specify a length, and this is the length of how much information we would want to store in the field. Lastly, we have data validation. Validation is done to ensure that the data that entered is allowable and sensible. Data validation does not mean that the information is correct, it just means it's acceptable. There are four main types of validation. Starting with presence check. The presence checks make sure the user has entered a value into a particular field. Restricted choice. This means that the user can only select from a list of possible options. Field length ensures that the data entered has a set number of characters. For example, your Scottish candidate number has to be 9 characters long, so a field length check would make sure this happens. And lastly, a range check. And the range check ensures that the data entered in a field is between two values, or it's above one value, or it's even below another value. Let's now have a look at how we put a data dictionary together. So looking at this example, we have a problem statement on the left-hand side of the screen and a blank data dictionary on the right-hand side of the screen. Our problem statement says SportsStats website uses a relational database to store details of Scottish sports teams and players in two separate tables called player and team. To minimise data entry, SportsStat applies the following restrictions. We'll have a read of those in a minute or two. Sample data stored in each table is shown below. So in order to produce our data dictionary on the right, the first thing we have to do is identify the two entities within this database, which in our case are player and team. Now that we've identified the two entities, we need to identify the fields within each of our entities. So for player, that is player ID, team ID, star rating, first name, last name, and date of birth. For team, that is team ID, team name, sport, manager, coach, and lastly hometown. We now move on to look at keys. Now remember, each table needs a primary key, and because these two tables are linked, they will require a foreign key between them. So, looking at the different fields within our player table, we're looking for unique values. Now, whilst in this example, star rating, first name, last name, and date of birth are all unique, we need to think about this in the real world. For example, the chances are there's more than one player with a star rating of 3. So it's always safer to go with a field name that is ID, reference, and number. And because we're talking about a player, the player ID is going to be our primary key. So we put PK. And then on our table team, again, the same idea. Let's go for the one that says ID, reference, or number. So team ID will be our primary key. Next up, we need to identify our foreign key. So you remember the foreign key is the primary key in one table located in the other. So if we have a look at in player, the primary key is player ID. Looking in team, we can see that the player ID does not appear. But looking at the primary key in team, being team ID, we can see that appear in the player table. So that is our foreign key. So that is FK. We now need to think about the type of data that each of our fields are storing. So we can store text, number, date, time, or Boolean. So our player ID is going to be text because it has got a combination of letters and numbers. Our team ID is also going to be text because it starts with a 0. Star rating can be number. First name can also be text. Last name can also be text. And date of birth will be date. Now looking at our team table, I will very quickly do that. Now we need to figure out the length of the field. Now we only need to worry about the field length for text fields. So for example, player ID, in our example, all the lengths are 4 characters long. So let's just set that to 4. And the team ID, they're also 4. Star rating is a number, so does not require a length. First name, we need to pick a length that we want this field to be for first name. For names, I normally go around about the 20 mark. Team name is also text, but being slightly longer, we might want to put a little bit more in it. So you're just picking sensible numbers to be the length of these fields. Next up, we need to do required. So this is essentially like a presence check, ensuring that the user has entered information if need be. Primary keys are required. We cannot add a new record into our database without a primary key, so they are required. Likewise, we can't add a player to our database without putting them in a team, so our foreign key is required. So star rating, first name, last name, and date of birth all have entries for each of the 3 records, so we can assume that they are required. So we'll put a Y in each of the boxes. Looking at the team table, we've got some gaps in manager and coach. Therefore, that information maybe isn't required. So we'll put a no in those boxes. And lastly, we need to think about validation. And this is our restricted choice, our length check, our presence check, and range check. And we get this by reading the problem statement. So for example, here it says all players must have a unique player ID that has 4 characters. So the length of that has to be equal to 4. Okay, because it says all players must have a unique ID that has 4 characters and the length has to be equal to 4. Players are given a star rating between 1 and 5. So star rating is a range check because it has to be greater than or equal to 1 and less than or equal to 5. The website features a limited number of sports: basketball, handball, hockey, and netball. That means each team has to play one of those sports. So that is a restricted choice. So let's put those choices in. So it's basketball, handball, hockey, and netball. So there we have the complete data dictionary for sports stats. Now that you know how to produce a data dictionary, I would like you to go and produce the data dictionary for Sunny Days, the travel agency. All the information you have is on the screen. Make sure you read it carefully whilst producing your data dictionary.